The 1955 eruption of Kilauea on the island of Hawaii was a flank eruption on the east rift zone of the volcano, about 20 miles east of the summit caldera. The outbreak was preceded by hundreds of earthquakes, some of which are here being recorded on a low magnification seismograph. Just before the outbreak, cracks opened in the ground as the rift zone was torn open. The formation of a new volcanic vent begins as fume pours from a crack. The fume is mostly a mixture of steam and sulfur oxides. Finally, a slowly expanding bulb of viscous lava appears. This bulb is only 3 or 4 inches across. As activity continues, a small spatter cone is built at the vent. This one is about 10 feet high. Showers of spatter falling on the side of the cone build it up. A closer view shows the rapidity with which the blobs of spatter striking the cone cool and darken. The cone built by this typical Hawaiian activity consists of thoroughly welded spatter. It is quite different from the cones of mostly loose cinder built by more explosive eruptions, such as characterize most continental volcanoes. Here, a lava flow has buried a small vent, and gas from the vent is bursting its way through the overlying, rather viscous lava. A small flow of pahoehoe, the smooth-surfaced or ropey-surfaced lava, issues from a row of spatter cones. The flow is about a foot thick at the edge. The smooth or billowy surfaces are much more characteristic of pahoehoe than is the ropey surface. These views illustrate well the typical mode of advance of one common variety of pahoehoe flow. Larger flows of pahoehoe are fed almost wholly internally through lava tubes. Here, the lava fountain at the vent has grown to a height of 250 feet. And in this spectacular group, the largest fountain is 800 feet high, a great jet of molten lava playing for hour after hour. During this period, the rate of lava extrusion was about 500,000 cubic yards per hour. The temperature in the core of this fountain, measured with an optical pyrometer, was between 1100 and 1120 degrees centigrade, or roughly 2,000 degrees Fahrenheit. Still another great lava fountain, 600 feet high, plays at the top of a cinder and pumice cone of its own building. And here you see a dark cloud of pumice blowing away from the fountain. This close view of the fountain, taken from the top of the cone, shows well the manner in which these cones are built. Fluid Hawaiian-type bombs striking the side of the cone kick up clouds of dust. Here, you are looking from the air into the crater of an active cinder cone. From a gap in the cone wall, a lava river, 25 to 50 feet wide, leads seaward, feeding the wide black margins and active front of an flow. Flows, in contrast to Pahoehoe flows, are fed largely by open rivers. Near the vent, this river of very fluid-appearing lava, 12 feet wide, spilled from a broad pond at the base of the cone to feed another flow of Although this lava appears very fluid, its viscosity actually is about 1,000 poises, or some 20,000 times that of water. Here, the river rushes down a slope of 30 degrees at a speed of about 35 miles an hour. On a gentler slope, it moves more slowly. A close view of the river. Again, the river plunges over a steep slope, dividing and reuniting like a braided river of water. The cascade is about 25 feet wide at the top. Clouds of volcanic fume and smoke drift across the surface of the river. Is the type of lava characterized by a very rough, clinkery surface. This typical flow front is about 10 feet high. The flames result from burning of vegetation being buried by the flow. The lava flow pours onto a paved road. Here it plunges over an 8-foot road cut, making a miniature lava fall onto the road. Note the bright incandescence of the lava, even in daylight. A glimpse of the flow front at close range. The flow moves on between piles of rubbish pushed up by bulldozers in clearing the land. The flow front averages 10 to 15 feet in height and is advancing about 1,000 feet per hour. It illustrates well the typical mode of advance of an flow. The flowage takes place in the internal, still mobile, pasty portion, visible here as the red part of the flow margin. The partly cool, black clinkery surface portion of the flow is merely rafted along on the mobile portion beneath. As they reach the flow front, many fragments of clinker roll down to be overridden by the advancing flow, resulting in a motion resembling that of the front of an endless track on a tractor. The lava plunges over a 50-foot sea cliff into the ocean, sending up great clouds of steam. Here, you see the steaming flow front in the ocean. And from it there rises a jet of black ash, a so-called littoral explosion, caused by the violent escape of steam where water has entered the very hot interior of the flow. Tails of steam follow the larger fragments. Much of the material is black sand-sized glassy ash that commonly washes up on shore to form black sand beaches. The steam cloud rises high above the boiling ocean. Boiling water, rolling clouds of steam, and many minor littoral explosions provide a spectacular climax to the course of the flow.